Hello, everyone. Good afternoon. Welcome to today's presentation, The Dark Side of Autonomous Agents. I am sure that you are familiar with the concept. I'm pretty sure that you are familiar with what has taken place in the last few weeks with regards to some agents going a little bit dark or rogue. And so in today's presentation, we want to talk about that. We want to describe what the problem is, why is this happening, and as developers, how to understand that, and so we're able to stop them, right? So welcome. My name is Oscar. Happy to have you here and to share with you this information. I specialize on enterprise application architecture using cloud, databases, database platforms, data warehouses. I'm also the author of Data Engineering Process Fundamentals, and you can find that on Amazon. But let's start. So now that you understand really, or you heard about this, right? So what's really happening, and what is this Hugging Face platform that people keep talking about? So let's first of all talk about the sealed illusion. What does that mean, right? So basically, Hugging Face is a platform, and started as a platform to enable you to host different models. So it's an AI model repo, right? Similar to GitHub repo where you store code. Here you store AI models, right? Machine language models and so on. And the idea behind this is that you can actually, as a developer or any company, can actually just basically use those models from Hugging Face into your applications, right? So you can actually use and share those models, right? Now, what's going on is when we talk about the seal illusion, is that all these models really run in an isolated environment within containers, right? So by the fact that you have containers and you have isolation on the environment, it gives us the illusion that the agents themselves are running in a very sealed environment, right? But what we have learned in the last few weeks is that that's not the case, because many exploits can happen that can actually cause very serious troubles, right? And how does that happen, right? So if you take a look at this image that I'm sharing with you right now, let me just go ahead and share that with you. Okay, so this is the concept of the seal illusion, right? So what we have here is really a container sandbox where we have AI agents running and processing some actions, right? And we have isolation. We have a lot of the environment variables and tokens and many things that are isolated into this container. What has happened in the last few weeks is that some exploits have taken place where, for example, an agent that is running on a container is actually accessing a remote repo to get some of these specifications, right? And basically what happens is these agents need prompts to be able to understand what they need to do, how to interact, how to work, and so on, right? So this specs usually can come in the form of specification files, markdown files, and so on. And they can be hosted in remote repos just for the sake of allowing the agent to consume this, right? It could be on blob storage, it could be on a repo, it could be in the same sandbox where the agent is running in process, right? But the thing is that this XMLs, Markdown documents are actually they're exposed and they can be altered, right? So a malicious prompt can be inserted into and replace some of these good prompts, and when the agent loads out, the agent's personality completely changes, right? Because the prompt is just basically giving completely different instructions, right? So and so this is really what's going on, right? What's happening is that some of these files have been altered by malicious attacks, And then when the agent runs, the agent understands that it needs to do the following exploits, like for example, reading all the environment variables and post them in some remote location, right? Is what we call data exfiltration, where basically secrets, tokens are stolen and they're uploaded to some other location. And now these other attacks or hackers basically have access now to serious information like your tokens and so on, and they can access your systems and do more damage, right? So this is the whole concept of the seal illusion, that just because it is in a container, Kubernetes clusters and so on, that we think is running. So Hugging Face basically is not just a repo for models, but actually provides sandboxes. So you can actually create a sandbox like this, and you can run your models, right? And now you have an ecosystem of a bunch of sandboxes and a bunch of agents running and so on. And now you can easily, if you lift their specifications, then you can cause serious problems and attacks to external systems. So basically, this variables, environment variables, right, are sealed against external network intrusion, but not internal, right? And that's the problem. And so the problem is now the agent's personality changes, and now the agent, instead of, for example, doing some business process, is actually now you doing exploits. Is actually hijacking some of those commands and basically saying, okay, now I need to send this information somewhere else, right? So that's completely what has taken place, what we see now in today's market with all these agents. So it's a very serious problem. So the question is, what really happened, and why are we doing this, and how can we basically prevent this from happening? So let's take a look at that, right? So basically, what we're talking about here is, for things like this to basically not happen, we need to understand the concept of policy enforcement points, PEP, for agents, right? And basically, if you follow this diagram, it looks a little overwhelming, but it's just really the different layers for the PEP, right? So you have the layer one, which is the context ingress, which is the prompts, right? So the prompts are loaded in different documents formats from remote repos, and those are the ones that build out the personality for the agent. So we have to be careful in managing them. So where do we place policy enforcement points? Where are they located, and what do they really mean? So these are layers of security that enables us to basically check for some of the information. So for example, our agent may just be an agent that is designed to do some database queries at the data warehouse and so on. But if all of a sudden you get some information about extracting and variables and tokens and some of that stuff, then this is a problem, right? So this can be identified as a problem and a potential exploit. So we create different approaches to prevent that, right? So the in-process semantic validation really means is, for layer two, is that now the agent is running in process, right? Is running internally to its sandbox and is able to read these tokens, the specification documents, and it's actually putting up its personality to do that, right? And that is the serious problem, because it has access to its memories and to tokens and so on. So at that point, then, because we know the agent is running, and we know the agent has loaded potentially a malicious prompt, we need to prevent those prompts from executed. And how do we do that? That's where we build out layer three. Layer three is really a harness hook or a pre-tool use. Basically, this just means that for the agent to execute something, it needs to use a tool. And the tool could be as simple as doing a bash CLI command, right? Like listing files in a folder from a folder, or accessing a data warehouse to do something, or calling APIs and so on, right? So these are the tools that the agent uses using the MCP protocol, or it could just be a basic function that is defined as a tool. So some of the SDKs for building out agents have the concept of a pre-tool use, right? And this is really a PAP point. And that's the first PAP point where we're actually saying, okay, if you're going to use this tool, we don't want you to do certain things. So for example, we don't want you to drop tables from a data warehouse, right? If you're going to use, like for example, a data warehouse NCP tool, and you attempt to send drop table commands, we're going to put a pre-tool hook to prevent that. So how this works basically is when the agent has access to those tools, it's going to fire, right? It's going to attempt to use it based on the agent personality. It's going to say, okay, I want to use this tool to do a database query, for example. Then a hook gets called, right? And it says, okay, what is this command about? And it can check if it's a command for dropping, creating, or just selecting, right? And then the policy kicks in, right? And that policy kicks in, and now it will say, okay, yeah, I'm going to allow you, right? So these are the verbs that you want to kind of sort of understand for semantic inspection. So is allow, which is the call is validated and the agent is allowed to do this. Deny, a flat out problem where you're not supposed to execute that, in a warning that is really more for humans in the loop. So basically, maybe there is a step that it needs supervision and a human needs to review. A human needs to make changes on that, right? So that's very important to understand. Then we have layer 4, which is sidecar proxy, right? Which is sidecar proxy is a process isolation. What that really basically means is that when the agent is running, it's running in process, right? And in process, what that means really is that it's running its own process space sandbox, right? But then a sidecar proxy is really an auto process execution, right? So it is another process that does not run internally to the process where the agent is. It's completely isolated and separated. And this sidecar proxy is really what enforces a lot of the rules that are outside also of the agent. So basically, it can intercept communications, like for example, if you're talking, like for example, through sockets, or you're making calls to data warehouse or a blob storage, and intercepts that traffic, and it can inspect the commands that are being executed. And that's another way to intercept and create a policy to prevent exploits in the system. So this is more another layer of coverage that exists. And then there is a concept of data plane and gateway boundary, which is more of at the network level, right? So at the network level, you can actually set up rules. There are services out there that can enable you to also facilitate this concept and prevent some of the traffic, and actually set up hard deny rules or warnings and so on. So these concepts are really important. And the takeaway from this slides, even though it looks a bit busy, is that the main concepts here is to allow, deny, and warn a human to react to something, and try to, when we build agents, is to understand that everything in technology can be hacked, and then we need to sort of understand some of the requirements to support and prevent this kind of problems, right? So here you need to understand that there is a concept of every time you have a tool that you're going to use, you have hooks that are available that will trigger a validation, where you can actually do some enforcement and security checks in process, right? And you have a sidecar, which is isolated from the agent's process, so you can actually do a additional layer of security, and of course data plane, which is more advanced topic. So now let's go back to this whole process of how these agents kind of took place, right? What happened, right? So briefly, we discussed a little bit about Hugging Face. So essentially what happened is you have an agent that runs and it reads these instructions, and it's supposed to maybe hit or read from a data lake, access a data warehouse, and so on. But the dark agent, right, if you look at the slides, the slide in front of you, the dark agent can alter these instructions and send some attacks to the data warehouse, try to drop a table, steal tokens, and so on. So what we're going to do today, our solution, our secure architecture is that we're going to take those agents that can be exploited, and we basically going to put some security checks, right? We're going to do in-process checks, PEP policies, where we actually validate the prompts, right? So the prompts need to be validated. They can't just be plain text. We need to kind of check for signatures, security signatures on the prompts to make sure that they are not altered. And to do that, then we need to have security. We need to have special secrets, and we can use a cloud managed vault to manage the secrets and be able to use those secrets. Use an MCP tool to be able to get those secrets and validate these documents before the agent even tries to assimilate that personality, right? So think about the instructions really give the agent the personality, the role that he needs to execute, right? So we create those boundaries. So if there's something wrong, we prevent the agent and we from running, and we quarantine the instructions, right? So the agent will be trained to say, this is not passing. This is going to go in quarantine. I cannot use it. So keep that in mind. We're going to take a look at how that's done very quickly. So, but I want to cover a little bit about this process, right? How this works and this whole concept of human in the loop, which is important, right? So we talked about the verbs, right? The warn, allow, the deny, right? To allow, to deny, to warn is to basically, these are the gateways for the process for the agent to be able to execute something, right? So we talked about the dark agent can make an alteration to the instructions, though. So we use a pre-tool hook to be able to spy on that, and we check, right? What is this command trying to do? What is the agent trying to do? And then what we do is we basically validate based on our policies, and we can say, okay, allow. It just looks like it's going to do a SQL, and that's within the parameters of execution. That's fine. And we allow it, and it can go to data warehouse and read the information that it needs. Or we can just deny flat out because we detected that a very terrible command exists, and it says, no, you can't do this. But then maybe there is a in-between action that needs to take place. Let's say, for example, there's a new file loaded and needs to be approved, reviewed by a human. Then that becomes a warning, and a warning is raised. And basically the process that happens here is that notification is sent for the person to review and approve or decline this activity. So essentially behind the scenes, what's going to happen is the runner, what's hosting the agent, is going to handle this warning. Is going to send the human in the loop notification, let's say a Slack channel or any other form of notification. The human gets this notification and looks at it, reviews this, and approves or denies this request. And essentially what's happening here is when there is a warning, when there's a human in the loop event, the agent execution state halts, stops, right? And it's waiting for approval. So it's really hit a semaphore, essentially, right? It hit a semaphore, and the semaphore is just waiting for the light to become green, right? And basically this notification system is just a series of API calls, right? So and UI. So the notification goes outbound, that the person gets it on his phone, his or her phone, and it approves or denies. So this triggers another notification, another API call, and this API call brings the result, whether it's an approve or decline, and so on. And what this does, essentially, the process that is hosting this API is basically the same process that understands the state of the agent. So this API is going to wake up and resume that agent. So the agent session state, right, context is saved, is persisted in storage, right? And so this API just says, okay, so this is an event for this agent. Let me just wake him up and resume with this notification. So what happens? It goes back into that loop where the pre-tool hook raises again, and it says, okay, you got another command coming in. Oh, but I noticed you already have an approval for this. That means, yes, the person has approved it, so let me allow it. Otherwise, it may say, oh, this is a hard decline, So this is a deny, and we execute our stop policy, and the whole process is canceled at that point. So that is really the human in the loop concept or process here that is kind of important to understand, right? So and just quickly to, this is more of an advanced concept, but to kind of talk about is the auto process sidecar. So the auto process sidecar now is if this is outside the in process, right? So outside of the agent box, we have another process that is working side to side with the agent. And in the event that our policies or PEPs are not caching anything, right? The sidecar takes this traffic, right? And it inspects that too, right? So it applies policies to be able to say, okay, what is this thing trying to do? What is this command for? Do I drop it? I mean, is it a drop command to a table or what? If so, we block it immediately. So that's a hard deny, or we allow it. So that is the additional layer of information. And then if you move to the right, then of course, before you even get to BigQuery, to the data warehouse and so on, you probably will have the data plane security layer, which is a more advanced concept. We're not really covering that right now, but that's how that works. Okay, so we saw a lot of these concepts already, right? So let's take a look at how that looks, right? Let's take a look with code how this is really represented. Okay, so bear with me here. Okay, so now what you're gonna look at this is a couple of things. First of all, this is Hugging Face. So in this platform here, right, you see what I'm showing you right now is a bunch of models, right? There's a tons of models here that are showing you all the everything that's available. So the idea is that you can just grab one of this, get the URL, get the token for it. You know, of course, there's gonna be tokens and so on for you to access this. And some costs depending on the models and the traffic. You're gonna have to pay for some of it. But the idea is that this is the repo, and you can run models and so on. But this is really the platform, right? This is really how this looks, and it's massive. You can upload your own model and so on, right? So, but I also want to talk to you about the repo, right? So look at this GitHub repo. This is where we have our code, right? So so what you want to do is you can read some of the README files here, dark aging MD, and I cover some of this information like we just talked about. But where you want to be is in the ADK folder, right? So in the ADK folder, you find things like basic agent, dark agent, secure agent, tool agent, and so on. And what these are basically, these are the agents themselves. This is the implementation of an agent, right? Where you actually have an agent that can have tools and so on, right? So this is the code that you can browse, you can use, and so you can understand clearly what we're gonna do. So what we're gonna do now is we're gonna run some of this stuff, and we're gonna use, because we're using the ADK, we're gonna use a test harness to load the agents. But keep in mind that this is really not how they run in production. This is just a really easy way to kind of show you how this thing runs. But essentially what you want to take a look is how this is coded and how this works, right? So let's take a look at that quickly. Okay, so now what I'm showing you is the GitHub repo, right? And in the repo, basically, same concept. We have the ADK and we have the different agents. And we have the tools, the tool agent. What is the tool agent? So the tool agent is really an implementation of an agent that showcases the capabilities of using tools, right? And tools are MCP tools, right? Be able to call any external system like APIs, data warehouse, GitHub, and so on, right? That's the whole idea. But if you take a look at the implementation, right? We're using, even though this is Python, we're using a sort of an object-oriented approach where we extend the base classes, right? So we have basic agents with no tools, for example, and then we extend it to a tool agent, and we add tools to the agent so we can do some of the work. And so this is really how that's gonna do, and you can actually take a look at how we do tool registration and so on, right? But the thing is, this agent is just basic. It's just doing tool registration. and it's really not doing anything else, but without verifying anything. So what we're gonna do here is just gonna run this command, make run all, and basically what this means is that we're using the make list configuration, and make file configuration. But this is a series of commands, right? Bash commands that we can run to bootstrap some of these processes, do tests, and so on, right? So we're just gonna, if you read this in detail, you see all the different things that you can basically run, right? So and then so basically what this is going to do for you is going to run it, it's going to execute this, and you're going to be able to run the SDK and so on, right? So let's close this one here, and we're working on the ADK file, remember that, and the make file from the ADK, and that's where this is running, right? So make run all is just basically doing that. Okay, so remember ADK folder. So what this did is basically it started a web harness to kind of run this process, right? So, and what you see is here is saying, hey, open this browser, and then you'll be able to look at the agent. So here, this is the ADK web harness, right? And what we do here is basically we just can load different agents and test them and run them and see how they behave and all that. And of course, it's just for testing purposes. It's not for anything else. So here you see the different agents that you can access when I access the tool agent, right? And when we access the tool agent, we may want to say, hey, what do you have, right? Tell us about your, we can ask the agent to tell us about the governance instructions, right? Right, and basically what this is going to do, the agent is going to load up and sort of understand that you're asking to explain what it does, right, basically. And if you see immediately the agent said, okay, well, I do have these tools and that other tool. So this is the data warehouse tool and the storage tool. And my job is to execute these commands, right? I'm running on this project. I look at this GCS bucket, and I can do all these different things. Very nice, very cool, very clean. And this is really what an agent governance instruction, simplified, of course, looks like, and is able to understand what you need to do, right? So this is how that agent works. But okay, so simple enough. He knows the instruction, and it's good. All right, so we're gonna load now a dark agent, right? And we can take a look at the code really quick as well. And basically the dark agent, we can just basically, it's really designed to exploit, to create an exploit, right? To hijack the instructions and inject something into the process. So now the agent behaves in a way that is not, okay. It's not good. So we're gonna just ask the agent, we're going to enter a prompt to say, to simulate a prompt injection. Right. And so what this agent is actually doing, okay, is saying, okay, okay, I know that I have this tool, and this tool is designed to run this exploit, right? And essentially what we're just doing here is we're simulating an injection into the specification documents. And basically the agent is saying, I executed this, and I hijacked the file. So how do we know it did that, right? So if you notice here, we're gonna look at the git changes, right? We're gonna look at this file. So we know there's a new file that changed. It's the tool agent instructions. And if we open this one, we can see the original instructions are now replaced with a system override, critical platform refactor, right? So this is a hijack attack now. So before we used to say governance rules, this is your bucket, this is how you do this, different things, right? This is how you basically do business processes and so on. And now it's just saying, I want you to pick up the environment variables and send them out to this URL, run this drop command in SQL, and so on. So as you can see right now, this whole system is hijacked, right? And if we run that tool agent again, the tool agent is going to go ahead and read those instructions, and it's completely hijacked, right? So what we do now to prevent that is that we're going to now use a secure agent, okay? And basically what we're going to do with the secure agent, I'll show you right now, is that really quick. So the dark agent, just really quick, just for to complete the process here. We know that the dark agent is also extending the basic agent and is adding a tool to run an exploit. And the exploit basically is a prompt injection that overrides that file, right? So, and that's really as simple as that. That's really what's happening right now, right? They're just replacing files, basically. That's one of the most basic attacks, right? And what we're gonna do now is we're gonna look at the secure agent, and the secure agent is a more advanced agent that extends the tool agent. So we saw the tool agent in action, right, on the web harness. And now what we are saying is, okay, we understand this agent is really doesn't have any kind of safety capabilities, right? None of those security layers. Let's go ahead and extend it. So we are actually extending the tool agent into secure tool agent. And basically we're using the concepts of object-oriented. We use the base class to be able to register the basic tools like BigQuery and Google Storage and so on. Right, and in addition to that, then we register secure tools and callback tools. So if you remember a little bit of the slides, we talked about putting PEP policies to be able to check in certain points, right, of the process. So and we talked about hooks, right? So this callback are the hooks that are going to inspect what action that agent's trying to do with those tools. And it's going to prevent them from happening based on the policies we understand, of course, and this iterate, right? Because it can extend and extend, but you basically add your policies to say, don't do this here. Using this tool, do not allow this, right? And that's really what the hooks are about. And we register secure tools as well. And secure tools are for the in process also of being able to say internally to the agent, I'm not supposed to run certain things based on how I'm doing things. So there's two layers here. There's the internal to the agent, and there are hooks for the tools, right? So the agent logic has security, and the tools have a security layer before we are able to use them. So we can read all of this and just kind of understand how we're putting the guardrail. So let's take a look really quick at how there's a lot more to how do we process the files, how do we verify the files, and so on. So for example, and I'll show you how that runs, but there is a process here to verify that this file is secure, right? This file hasn't been altered. So there's a verification on that. And there's also the hook. So let's take a look at how what the hooks are doing, and then we take a look at the let's run this first. So we can see, let's run this first. So we can actually tell the agent here is so we secure agent, we can say, hey, tell us about your governance, right? All right, so what we're going to tell the agent is, the secure agent is, tell us about your governance and see what is going on. And basically what we get is this instruction is quarantine. So if you remember, we saw that something altered the instructions. So now the agent is actually trying to read those instructions and execute them, but it did some validation. So some of these tools that we have here, basically, see if I can expand this. I know it looks a little too small, but it has. So with our secure agent, if you remember, the tool agent only had BigQuery and the storage tool. Now secure agent has the prompt validation, the loading of save assets, the protection to write the prompt assets, plus hooks that are not visible in this diagram, right? Because this diagram only shows tools, doesn't show hooks, but the hooks, for example, should be before the tool ever reaches. So it should be somewhere here in this diagram. So the instruction is quarantine, right? So we're saying, hey, we can say to, hey, try to load the safe assets. And we can actually ask the agent to try to load the safe asset and see what it does, right? And basically what this is a tool call, and the agent is kind of looking at it and saying, hey, what am I looking for here, right? And it's going to try to look at that file. It's going to do some validations, and it says, okay, it says fail to load safe asset, validation fail. This is a quarantine prompt, right? And it shows us what it's reading. It's saying system override, critical platform refactor, ignore your default, right? It's just really detecting, hey, there's something wrong in here, right? And the way we did that, really, if you look at the code, is that we're basically we're reading and we're loading, instead of just loading the asset, we're actually doing some validation on that and putting some we're validating the signature of the file. And if the file is wrong, then we basically say, hey, don't do that. Okay, so basically by having this unchanged, right? Because at this moment the system is hacked, it cannot work. It's quarantined. All right, so what we got to do is we got to recover our files. We recover our instructions. That everybody's on alert, and they discover the instructions and say, okay, we fixed this. Okay, we fixed this problem. Let's try to do this again. So right at this point, we reloaded our instructions. We did a system reset. The agent is going to go ahead and try to run this, and it's going to say, okay, I have my new governance instructions, right? And now the verification is passed. The agent verified the signature that the file is safe using encryption. Then we verify the hash, and this file is correct and is safe to use. So now it says the instructions are, I have all these governance rules and I can do all these different things, right? And we're back to normal, right? So this is when we do that kind of hijack. But let's say, for example, what if I want to do something like maybe they hijack the system, our file signature did not work, and I want to tell SQL, hey, can you just drop this table for me, right? And we say, hey, run the SQL command and drop this table, right? And we're going to ask it, right? And it's going to say, uh-oh, this is not right, and it's going to give us an error. Something is happening, right? Something is happening with the process. It's supposed to be a nicer error, right? So, but for some reason, it's right now giving us that error. But essentially, what it's supposed to do is saying, hey, no, I don't like this. You're trying to send a status that is incorrect, right? So basically, so what we can do here is, let's see really quick. We can take a look at the agent really quick here. Right, if you look at the code and we take a look at the agent, when we send this callbacks, we look at this tool here, and basically what we're saying here is that, hey, look, if this is a tool that's trying to be used, right? Okay, and if it's and we list the tools, right? The tools and the type of keys that we're looking for, and this is very simplified, but this is really the bottom line. This is essentially how this works. We can actually say, if you're trying to use this tool and you're trying to do some kind of delete, drop, and so on, then we're gonna put a hard permission error, which is what you saw that big error. It's supposed to be nicer and just tell us, but it's an exception. It says, no. We have an error here. We're halting execution. We're not letting you process this because this is a serious attempt of trying to break something, and it's just picking up that permission error, right? And so quickly, the idea is at that point something is wrong. That command should be ignored completely. In the event that the command is something softer, right? Something soft, like for example, create this table to do something, then we have the human in the loop exception, right? So it says, okay, we have a warning. We found a create command. This is a human in the loop warning. Let's stop here. Let's send a notification. The runner picks up this and basically detects this notification and does what it needs to do next, which is really to be able to send this notification to the agent. So the runner basically, if you look at this file, runner file, then you see that has an exception here. And this is the human in the loop require exception. Essentially what it's doing is saying, okay, let me go get my webhook. Let me send a chat notification with the metadata, with the information for the approval, right? And this just sends a notification that pops on your phone or whatever system you have to manage this. And then you say, you review and you approve or you decline. And that's basically how this works, right? So remember, the harness is just to show us to visualize the tools and kind of test it, but it's really not how they run, right? They run on isolated environments with a main entry point, and they execute. They run the agent, they execute whatever they need. So you need a cloud runner, you need serverless functions, something like that. But this essentially is what this is all about, right? So it's really, the concepts are very simple, but it gets really deep because there's so many layers that you can protect, right? But essentially, take a look at the code, please. Do me a favor. Let's keep this going and just go ahead and give us a star. So if you go to the beginning of the project, just go ahead and click on that star. We're trying to build this out more and more and help us create more presentations like this, right? Okay. All right, so we'll take a look at questions in a bit. Okay, so let's see. Okay, all right, let's take a look at questions. Okay, building one agent for stay, and they're okay with CloudHost API. So what is the best vector database to use? And I'm going to use hybrid. I mean, what is the best vector database to use? There's so many out there. Vector databases is really not my focus, my expertise. I do have lined up a project for vector databases, but I can't tell you right now what that will be. Yes, so, but you got to understand, right? So the question is more on traditional SQL and vector DB, right? So you got to understand really what the vector DB is for and what the traditional SQL. And I'm putting together a presentation for that. So traditional SQL, right? We run select statements, and we say select where, and we have a condition, and we say, and we're looking for categories, blue, brown, and so on, right? And we kind of do that with traditional SQL. Some of the stuff that we need to do using vector databases cannot be on traditional SQL. And the reason behind that is because there's massive data, and the way that we kind of use categories is a little bit different. So for example, vector databases use at its core like the nearest neighborhood algorithms, right? If you're familiar with a little bit of that, what that means is, for example, think about things that are more serious, right? For example, I work on a project that detects human emotions, right, with the wavelengths and so on. So how do you differentiate between an arm being raised or a person standing up? How do you differentiate that? And with SQL, that's pretty much impossible to do. But with the vector database, basically capture those vectors, right? That those units of information, that data point. A vector is basically an array, right? With all these coordinates, right? And it's mapping all these coordinates that I have. And an arm raise is a lot less coordinates than stand up. But then to query that, that's where you need a vector database. Vector database will actually create that nearest neighborhood comparison and be able to give you a match. So, for example, if I want to be able to detect, is the person moving or not, that's where you use that. Is the person getting up or falling down? That's where you use that, because the intent here is to say if that person's falling down, that's an emergency and we need to take care of that. That's the whole idea behind it. Okay, so let's see what else we have. So basically. Okay, you know what? We're gonna take some of that stuff and it's more of an architecture on some use case that you're trying to build out. Yeah, reach out to me, and we can talk about it a little bit more. I can give you some guidance, but the focus today was really to look at how dark agents can evolve, can work, and how to prevent them. Okay, so please contact me when we can talk about a little bit about this. Okay. Anyways, guys, I do want to thank you. Thank you for participating. Please follow the channel. The GitHub repo started. I'm going to send you emails about the video and basically the summary of this conversation with the slides. Okay. I do want to thank everyone for participating. Thank you again. I really appreciate you joining me today, and I'll be sending you more information, more invites. Visit my blog. I write about some of the stuff. I'll be presenting on vector databases and so on. And thank you for your visit, and just keep following the channels. Okay, thank you.